Today, from section 5.4, we're covering the triangle midsegment theorem, and from section 5.5, we're covering the triangle inequality theorem. First, a little vocab. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. So if we're looking at midsegment UQ, it's joining point U, which is the midsegment of side PT, the midpoint of side PT, and Q is the midpoint of side PR. Looks like QS is also a midsegment. We've already marked Q as the midpoint, but S would also be the midpoint of side TR. And in our other triangle, DE is a midsegment. Now, every triangle has three midsegments, which form the midsegment triangle. So in our diagram, segment XY, segment YZ, and segment XZ are all midsegments. They form the midsegment triangle XYZ. Now, a little bit of information about midsegments. This is the triangle midsegment theorem. It says that the midsegment is both parallel to the third side of the triangle and is half as long as the third side. So here they're referring to, let's go orange, XY and PR. So XY is our midsegment, and it is intersecting with two of the sides, PQ and QR. So therefore, the third side that they're referring to is the one that it's not intersecting with. That would be PR. So you can see both of these relationships in the theorem written out. It is both parallel to the third side. We could add some markings on the picture, and it is half as long. So for example, if PR had a length of 20, XY would therefore have a length of 10. So let's investigate this information here in this problem. PQ is a midsegment of triangle CED. We need to first find the coordinates of P and Q. Well, if it's a midsegment, it connects two midpoints. Therefore, I know P is the midpoint of this side. So to find it, I'm going to do the midpoint formula with points C and D. So we're adding up our X values, adding up our Y values, and dividing both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And we're going to do the same thing with Q. We're going to use midpoint formula with C and E this time. -1 plus 3 divided by 2. 4 plus 0 divided by 2. Q has the points 1, 2. So that's the answer to problem A. Now problem B asks us to find the slopes of PQ and ED. The slope of PQ, we certainly could do the slope formula with these 2 points, but we could also count rise over run in the picture. So we're rising 1, running 1, 1 over 1 is 1. And the slope of ED Same thing, we could do slope formula with those points, or we could count rise and run on our picture. 2 divided by 2 is also 1. So notice we're verifying same slope means they're parallel. We just verified the part of the midsegment theorem that says the midsegment is parallel to the third side. Now we're going to verify the part that says the length of the midsegment is half the length of the third side. So let's find those lengths. We need to do distance formula to find the length of PQ. I'm using my coordinates that I found in the first problem. So I'm subtracting my x's and then squaring them, plus subtracting my y's and squaring them. 2 minus 1 is 1, 1 squared is 1, plus 3 minus 2 is 1, 1 squared is 1. So 1 plus 1, we're left with the square root of 2. And we're going to go ahead and leave it in simplified radical form. Now let's find ED. Set up our distance formula. 5 minus 3 squared plus 2 minus 0 squared. 2 squared plus 2 squared equals 4 plus 4, which is 8. So if I'm simplifying this, that's the square root of 4 times the square root of 2, which the square root of 4 is a whole number. It's 2 square roots of 2. And there you go. ED is twice as long as PD. We could put a 1 out in front there. Or we could say PQ is half as long as ED. Using the triangle midsegment theorem to find each measure. AC is a side of the triangle. It is parallel to FD. So we know this is the third, AC is the third side related to midsegment FD. So if FD has a length of 6.2, that means AC would be double that, and it would be 12.4. The measure of angle DFE, DFE is here. That's using side AE and its midsegment BD. Those are parallel sides. So notice the Z shape formed here. The measure of angle DFE would be the same as BDF. We're using the alternate interior angle theorem. So it would have a measure of 26 degrees. And lastly, we're finding BD, which is parallel again to that AE side. AE has a length of 17. So BD would be half of that, 17 halves, or 8.5. That's the triangle midsegment theorem. Now from section 5.5, the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we add up side AB plus BC, that has to be greater than the length of AC. Or AB plus AC has to be greater than BC. So they're doing all three combinations of two sides being greater than the third. And if you can verify that this is true, and this is true, you add up any two sides of a triangle and check that it's greater than the third, then that means a triangle can be formed. Let's talk about why this is useful, how this works. On the left, we're shown segments with lengths of 7, 5, and 4, and those do form a triangle because 7 plus 4 is greater than 5, 7 plus 5 is greater than 4, and 4 plus 5 is greater than 7. All three of those can be verified. Now on the right, we have segments with lengths of 7, 3, and 2. And 7 plus 2 is greater than 3. 7 plus 3 is greater than 2. But 2 plus 3 is less than 7. So this could not form a triangle. If you think about this, a side length of 3, if we dropped this all the way down, it would only reach out to here. And this side length of 2, if it dropped down, would only make it to here. We wouldn't be able to have those vertices come together to form the top of a house. We're missing about 2 units of length here. So that's why this theorem exists. So let's use it. Can the following side lengths be sides of a triangle, and explain why? So we need to check these expressions, n plus 6, n squared minus 1, and 3n when n equals 4. So let's plug it in. So we have side lengths of 10, 4 squared minus 1, 16 minus 1 is 15, and 3n, 3 times 4, 12. So let's go ahead and check. 10 plus 12 is 22. That is greater than 15. 10 plus 15 is 25. That is greater than 12. And 12 plus 15 is 27. Oops, sorry, let me write it out. That is greater than 10. So yes, a triangle can be formed. Let's do one more type of problem. We're given these two side lengths to a triangle ABC. We're given 10 and 12. What is the range of values for the third side? How short could x be that they still form a triangle? How long could x be that these would still form a triangle? So we're going to use our three sides, 10, 12, and x, and set up our inequalities. So 10 plus x has to be greater than 12. 12 plus x has to be greater than 10. And 10 plus 12 has to be greater than x. So again, I'm doing all combinations of these three sides. So when I solve each of these, I get x has to be greater than minus 10, 2, minus 12, minus 12. X has to be greater than negative 2, and 22 has to be greater than x. Or another way to think of this is x has to be less than 22. So these are contradictory. Well, they're not contradictory. X has to be greater than 2. X has to be greater than negative 2. So in order for us to form a triangle, all three of these have to be satisfied. So let's think about if we only satisfied this one and x was equal to negative 1. That would not work because negative 1 is not greater than 2. So we're using 2 as our lower boundary. X has to be greater than that, but it has to be less than 22.